This is Chapter 4, Sections 2 and 3 notes. Now these used to be two separate sections, but they go so well together that we decided to put them together. We're going to start with a little bit of vocabulary. So we're going to start with dependent variables. That's the value that depends on the value of the other variable. So this would be the y in an equation. Okay? This is also known as the outputs, the values of the dependent variable. Okay? So if you have an equation like y equals 2x, that y number depends on what you put in there for the x value. In a real life example, say you're thinking about going outside, the temperature that it is outside depends on the time of day that you decide to go outside. If you go outside at midnight, it'll be a lot colder out than it is at noon. Okay? An independent variable is a variable or a value that you can change independently. So that's the value that you can plug in or input. These are also called input, the values of the independent variable. In an equation, that is the x. Okay? In the time of day scenario, that is the time of day that you decide to go outside. You can decide what time of day you go outside. It's just the temperature is going to vary based off of that time of day. The next couple of vocab problems are linear functions and nonlinear functions. A linear function are all lines except vertical lines. So you can have slanted lines. They don't even have to be connected. You can have dots that form a line, or they can be horizontal lines. They're any line that isn't a vertical line. Nonlinear line is anything that's not a line. So you might have a parabola or a U-shaped, a cubic function, which looks like this kind of snake-like thing, an absolute value function, which is a V, so dots. Another type would be a vertical line. Because it's not a linear function, it automatically has to be nonlinear. So if it goes up and down like this, it's nonlinear. Okay, so that's our vocabulary. Then we get to actual problems. So, representing a linear function, it says the table shows the relationship between the number of photos x you take and the amount of memory y in megabytes left on your memory chip. Is this relationship a linear function? Describe the relationship using an equation and a graph. So remember that linear means line. Okay, so you want a straight line, no curves, no weird angles or anything like that. So, taking a look at the table that it gives you, you'll notice that on the x, you're changing by 1, so the number of photos changes by 1 each time, and the amount of memory y decreases by 3 each time. So, let's start by graphing this equation. So I just made a quick graph of the table. My x value 0, 1, 2, 3 go on the bottom, 0, 1, 2, 3, 4, 5, I went all the way up to 10. The memory starts at 512, which is really, really high up there. So it might be helpful to use 3 dots, which just means there's a gap there. You're not going to say every single number. So I started at 501 and went by ones. So I graphed at 0 photos, I had 512. At 1 photo, I had 509. At 2 photos, 506. 3 photos, 503. Okay, so this is looking pretty straight. So I'm going to say that, yes, this is a line or a linear function. The memory decreases by 3 megabytes each picture. So the only thing I have left is an equation. So for the equation, you're going to start out with y equals, and then this number is always your starting y amount. So we started with 512. So y equals 512, and then each step was minus 3, and it's always finished with an x. So y equals 512 minus 3x. Problem number 2 says, does this set of ordered pairs 0, 2, 1, 4, 3, 5, and 1, 8 represent a linear function? describe the equation using describe the relationship using an equation and a graph. So we're going to do essentially the same thing we did up here, but we're going to have to make our own table. So I'm going to just put the y's into an equation. I'm going to put them just like they were, 0, 1, 3, 1. And then I'm going to put the y's on the other side. So 2, 4, 5, 8. So notice how this is not the same. 1, 2, negative 2. And then this is not the same. 2, 1, 8. Now you'll see that this should probably not be a linear function because of those inconsistencies. And when you graph it, you'll see that the dots are all over the place. The relationship is what we call not consistent. It's not a constant line. It doesn't go straight up. It doesn't go straight down. It's just not consistent. So that would be a non-linear function or not a linear function. Okay. And then the last problem for today is classifying linear or nonlinear functions. So the area A in square inches of a pizza is a function of its radius r in inches. The cost C in dollars of the sauce for the pizza is a function of weight W in ounces of the sauce used. Graph these functions shown by the tables below. Is each function linear or nonlinear? So they give you these two tables, and all you need to do is graph them. So they also give you two graphs. So this first table is going to be my first graph. So pizza area, so remember this is the x-axis, so I goes 2, 4, 6, 8, 10. I just went by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. On this side, though, it goes from 12.57 to 314.16. I decided to go by 50s. You could have also gone by 25s and been fine. So I had to really guesstimate. So over 2 up to 12.57, over 4 up to 50.52, over 6 up to 13.10. Okay, so I graphed all of these as x, y points, and then I connected them. They were not a line, so that's what I call a non-linear function. So then this next one, I did the sauce cost. So again, I labeled my graph so I know which one I'm looking at. And for my x-axis, again, because the weight went by 2s, I could go by 1s here. And the cost actually went from 80 cents to $4, so again, I could go by 1s on my y-axis as well. So I made my dots the best that I could. So over 2 up to 80 cents, which is below $1. Over 4 up to $1.60, which is just over 1.5. Over 6 up to 22.4. Okay, so I made these, and they're mostly a straight line. So I'm going to guess that it's going to be a linear graph. Okay, so see the difference? Curve is nonlinear. Straight line is linear.